Good morning, GIS 300. Welcome to week number 6. So far you've made a series of maps interpreting patterns in point and polygon data. You've learned how to make maps and do some basic analyses using vector data. That deals with coordinate pairs, points, and the lines and polygons they can come to represent. Where a point is a location, 2 points can form a line, 3 or more points can form a polygon. Now it's time to start talking about raster data. And I think the best thing we can do is give you an example to start out. So this is the great and good state of Maine, and here are the Maine Department of Transportation roads category 3 and higher, meaning our highways. This is a lines data set, meaning it's a series of points connected. They have length but not width, and no area. They represent the center line of the road but not its entire width, except as an attribute if that should be attached. We are also looking at towns. That is also a vector data set, in this case polygon. Points connected by lines forming closed features. I want to create a raster surface called a Euclidean distance, named for Euclid. And I'm sure I'm butchering that pronunciation, but he was an ancient Greek mathematician. Now this is the difference between ArcGIS and QGIS. In ArcGIS, I could just say, give me a Euclidean distance off of this lines feature. In QGIS, you have to do just a couple of extra steps. Like so. 1. Right-click, open attribute table. 2. Go to your field calculator, bring that onto your main screen, and create a new field. I'm going to call this raster, equal to 1. OK. And that looks like so. That was about 10 seconds on my computer, so expect a minute or two for yours. Close. Next, we need to turn this vector layer into a raster layer. Under Raster, Conversion, Rasterize, Vector to Raster. Our input layer is our main DOT roads, and see how we still have that pencil there? That's still being edited, so I actually want to right-click on that, toggle the editing, and save my edits before I go forward. And now I'm going to use the field that I created before, the raster field. Next, we're going to set the output raster size units to georeferenced units, and we're going to set this to a 10 by 10. So there's a 10 meter by 10 meter grid of cells. And that's meters because that's the unit of our coordinate system. If we were using a state plane coordinate system that had the units feet, then that would be 10 by 10 feet, but we're in UTM, so meters. Finally, I have to give this an output extent. I'm going to use these 3 dots here. And I can calculate from a layer, such as the input layer, and see how that gives a rectangle, or coordinates defining a rectangle, for where it's going to process. What it's doing is finding a rectangle that bounds all of the data within that data set. So the southernmost point here, the westernmost point here, the northernmost point here, and the easternmost point here define that box. And that actually ends up cutting off part of Big 20, the township at the north here. So I'm actually going to change that to use map canvas extent, see how that changes, and now it's going to process everything that we see here. And with that, as long as we see all of this information here and not some warning, we can go ahead and run. And 73.2 seconds later, I have my output. That means when you hit run, it's probably a good time to go for a snack, or a walk, or some kind of a break. Anyhow, close. Zoom in, doesn't look like anything's happened yet, but once we get right in here, we can see that in fact it has worked. This line is now represented by 10 by 10 meter cells, and of course there's 1, 2, 3, 4 of them stacked up here that you can't see. But what it is a series of cells, each 10 by 10, that have the value of 1. The value of 1 here is what we generated before, and that just means there's a road here. We have 1s and implied 0s of no road. This is what we use for our next step. Raster, analysis, proximity, raster distance. Our input layer is rasterized. Band number is the default 1. Distance measured in georeferenced coordinates. Keeping our other defaults. Scrolling down. Save to a temporary file, open after running, run. And 288.18 seconds later, we have it. Just close that, and I'm going to go ahead and right-click, zoom to layer. And this is going to make more sense if I change the symbology type here. So under the min-max settings, I'm going to change that to the mean, give or take a standard deviation times 2. Apply. There we go. And just to change the visualization a bit more, I'm going to change the statistics extent to the updated canvas. Okay. If you remember from when we were looking at elevation models, as I zoom in, the color ramp will change, and the highest value and the lowest value will be represented. The highest value being white and the lowest value being black. Now I'm going to move my DOT roads on top of my proximity map so you can see what's going on. You can see the lighter colors are farther away from the highways. The darker colors are closer. If I zoom in even farther, we can see how it works. So this thing that sort of looks like a ridge here, this is the point farthest from either of these roads. Continuing to zoom in. See close to the road, farther from the road. Zooming way in, you can see the actual pixels that are making this model up. If you select that and use the Identify Features tool, you can click on any one of them and see what its value is. So right on top of it, band 1, 0 meters away. 10 meters away, 20, 30, 40, 50 meters away in a straight line there. If you're going at a diagonal, 63.24552. And looking at this area, we can see one of the things that makes the North Main woods unique. That is the lack of paved roads. There's woods roads, dirt roads all throughout it, but there's no pavement. And that is a unique resource. You have to go down to the Adirondacks in New York to get anything close. One of the most common things we do with a raster is reclassify it so it's either 1s or 0s, or 1s and no data. Like this. This layer is every raster cell that is within 100 meters of the road gets a 1. Everything else is no data. Now I made a slight error when I did this, and that left us with no data where the distance is 0. Let's go through how to reclassify this data set. So in the processing toolbox, which if you don't have it, View, Panels, Processing Toolbox, type in Reclassify and reclassify by table. Double click. Step number 1 pointed at the right raster layer, which is our proximity map. We're looking at band number 1, and we need to build a reclassification table, which we access by these 3 dots. And we need to add a row, and we're actually going to add 2 rows, because we need both. And the minimum is going to be 0, and the maximum is going to be 100. When the raster's value is between those, it's going to become 1. When it's 100.0000001 to 99999, whatever high value it is, we're going to make that negative 9,999. So it's either going to be between 0 and 100, and therefore be a 1, or between 100 and anything higher than that, and be a no value, negative 9999. Now we have to say OK. We don't do anything else, no cancel, no back. Have to hit OK, and that takes us back. Now what I did before that caused this gap here is that I used this default range boundaries minimum, then anything greater than the minimum. If the value is there, then it counts as a 1. Anything else gets no data. So when the value is 0, well, that's not greater than 0, that is 0, so that doesn't count. So we have to change this. So now it's min greater than or equals to. And we can also do a greater than or equals to there because we specified. When I say specified, I mean that we have this so precisely defined that there is not going to be any 100.000000001, or there's almost definitely not going to be. So we can anticipate that that's not going to be an issue. If we did happen to have 100.0000001, then that would result in a no data, just like this here. But that's very unlikely to happen because we put so many zeros there. Okay, now we can go ahead and run and expect that it's going to take 5 or 10 minutes. When it's done, we can close that. That took 167.98 seconds for me. Close. And now, with that reclassified raster, if I click on any one of those cells, it's 1. Anywhere else, no data. So now we have a swath around each highway, 100 meters from the nearest center line. And in the next video, we'll see some practical applications.